Okay, shh, we're live. Okay, good start. Okay, now remember, yesterday you were given these questions, and the only thing that you had to do was what we did the day before, I believe. Identify the null hypothesis and the alternative hypothesis. And then I did say this stuff. I'm just using this. This is actually next week. We're going to do proportion situations. But this stuff was just, and I think this one's wrong. This should be 347 divided by 425, right? Your survey 425, 340. So that was just a minor mistake from the teacher last year, McGrath, which using her keys, which is whatever. Good for me. But what I said was you're given the p-value. So what you're going to find out is this stuff actually will help you determine that p-value, and that's the extra today. So today is going to end exactly the same as yesterday. You're going to make a conjecture comparing p to alpha, the not confidence interval, but the significance, level of significance situation, and then make a conjecture about the null hypothesis. Okay, so the added feature today, actually a better example to show is one that's going to deal with what we're doing. Where is it? I don't know. It's more like these. Okay, so just get in your mind. Today, the extra step, the extra baby step is how do we get that p-value? And then answer these questions. Got it? Okay, so that's all I wanted to do. All right, let's see how this works, which may or may not be good. Here we go. We're going to give this a whirl. I tried this first hour, and it was a disaster. And that's a bad start. That's the last. Okay, there we go. All right. So far, so good. Okay, so we got the idea. Now, this is called a one-sample hypothesis testing, and then this actually has to do with what we did back before break. Just get this mindset again if you did your homework back then. Big if for some of us, right? Hey. All right. When the standard deviation of the population is known, you should remember when we did confidence intervals, that was a z-test, and we used our z-chart. Oh, by the way, get those charts out now. We should hear a bunch of shuffling papers. And the one that we're going to need today is the z-chart one. Okay? That's the one that looks like this, the area left of a curve, which left of the z-value. There's a front and a back. It goes from 0 to 3.4, and then on the back it's 0 to negative 3.4. Yep, just making sure I'm looking at my sheet right now. If you don't have one, I guess when you leave during 7th hour, I'm going to have to scan one and put it online, and it's your job to print your own. I'm done. I had 10 extra ones in that corner, and I swear to dog, there's a student with 10 of them laying in their locker because they took one every single day till they were gone. I don't see how I made 10 extra copies and they're all gone. You know what I'm saying? Aren't you with me on this one? Is it you? Do you have the 10? I think I said this yesterday. All right. So, remember, this is review. This is your how you analyze the null hypothesis, whatever it may be. And then what you were asked, and actually I'll stamp your homework, give it back, and we'll go over that key with your work in front of you. And then we can hash out those things if you still have a problem with that. But you analyze P compared to the, what's it, not confidence interval, I just did it again. Someone help me. The level of significance. Holy Lord. This is what happened first hour. This is why this is another Lord of the Manor. This like in a feudal system, nothing specific. Okay? All right. Or if P is greater than or equal to alpha, we fail to reject. Now, someone 5th hour did ask me, why do you say fail to reject? I think when I first produced the notes, I said it confirms the population, situation, whatever it may be. And that's not the wording. What it is you fail to reject it. So it's not been rejected, so we feel okay about it. It's not like a confirmation. so to speak, I guess, is the way we would have to word that. Okay, so now here's another thing that doesn't work very well when I do a PowerPoint. I can't really pause a video. I could try, but then something got messed up when I did it the other hour. So if you do have a question, we'll try it, but try to go along. And then those that have to watch this video, it's probably going to be longer because I can't really pause very well. All right, so left tail test, right tail test, two tail test. Here are the drawings of it, which might be smart for you to look at so you know how to look at your Z chart again. And it's exactly what you had to do, before break for weeks, looking at that chart and doing it. It was that rehash of Math 3 that you did, if you remember a couple chapters ago. That's what we did. We looked at the Z chart and then area left, area right, area between, all that other stuff. Okay, so if you find out you have a left tail test, remember that is based off of what the alternative hypothesis is. If the alternative hypothesis is said to be less than is numbers left on the number line. I think that's an easy way to remember that. So it's this shaded region. What you want to find are these probabilities. And actually what I should have put right down here, I should have put Z. Oops, all three of those weren't supposed to come up. I accidentally hit the screen 3 times. I was supposed to put the Z value right here. So I look up the Z score, and I look it up in our table. I guess we call it table A. I don't know. I copied that from McGrath, but we don't really have an A on this. But we just look out in the table that I gave you. And since Z is right here, this is how the sheet is constructed. It gives you the probability of, or the area left of the Z value. So that is the area you're looking for. That's the P. So you have to find P today. It was given to you yesterday. This is your job. If it's a right tail test, we got a problem. What again I should have put down here is Z is right here to the right of 0. Remember this, how this works too? This is 0, 1, 2, 3 deviations to the right, -1, -2, -3 deviations to the left. And it goes up to 3.4 on our sheet. So if Z is over here, you got to remember when you look up Z, they're giving you the area on that chart. Fine, I'll get my pen. They're giving you this area when you look it up in the chart. That's not what you want. You want the right tail. So what's the difference between the red and the blue? 1 minus the red equals the blue, right? Okay, so that's why we got to do what we got to do there. Okay, and then I'll get my ability to do this. And then for this, remember, when you get a Z value, this is this Z value. You really got to listen to this one. This is the Z value, and then this is the negative Z value. So say we get Z equals 1.7. That means this value is 1.7 to the right of 0, and this is 1.7 to the left. So why in a two-tailed test, no matter what I get for the Z-score, would I look up the negative Z-score? It's because of how your sheet is constructed. If this is, okay, I'm going to write this, make this better. Say, like I said, this is a Z-score of 1.7. And this is, therefore, a Z-score of -1.7, because this is how a two-tailed test works. You're 1.7 to the left and right. I'm just grabbing the Z-score out of the air, a number that. If you look up this one, the answer on the probability page is all that. Is that what mirrors the green? Yes or no? No. All right. So what's smart and easier is to, okay, I'll look up this one, because when I look up this one on the chart, it does give me this area, right? So all I have to do is do what to that area? Double it, because these are equal. So hopefully that makes sense why we do what we do there. All right? Oh, you got a question. I don't know if I could do that. Okay, go ahead.
Okay, so you look at the negative Z-score, and then you find the positive of that?
No, you just double it, because what I just said here, this area is equal to that area. So when I find this on the sheet, that's just this area, but the total of the green is these two added together, or doubling them.
Whatever you get, you multiply by 2?
Because of this drawing, yes, and because what you see is these probabilities. All right, so I'm going to move on, because actually this is on the next page. Maybe I'm going to move on. Uh-oh, working. That's always a good sign. Oh, no. It's not working. Come on, come on, come on, come on, come on, come on, come on. Okay. I can't work my hands, dude. This is fun. Oh, you son of a. We're frozen. Let it go. Oh no, that wasn't it anyway. Here, I got a chance. I got a chance. Are you cartooning me? Okay, we had a nice little internet interruption. So hopefully we can get this back going. All right, shh, here we go. Silence. Okay, now we're back. So we got that figured out, what we got to do. Remember our 2 extra jobs today. Silence. This kid here, problems. All right, now here's an example. Okay, so here's baby step number 1. How from information can I get the p-value? And then step number 2 is how do you get a z-value, which is just a formula. And then everything else that you're doing today is exactly the same as yesterday. So you read a question and you determine that it's a left-tailed scenario. Well, which of that does that emulate? The red, the blue, or the green up here? Which one is it? The red. So go ahead and look at your sheet right now. Look at z equals negative 2.2, 0, 1, 2, negative 2.23. Remember how that works? Now, I never had this on the internet. One guy I showed you did that chart perfectly with highlighting, cross-referenced it. What'd you get? Oh, my dog. All right, 0.0129. Now, is that red area, yes or no? Is that what I'm looking for? The answer is yes. Now, look at what's up here, and then you do what you did yesterday. Since P is less than alpha, do we reject or do we fail to reject? What was that for P less than alpha? Rejection. Okay, so that's a reject of that. Again, if you weren't here, this is the last 2 days what we've done. So we'll have to pick up on that. The next one, and by the way, why is it left-tailed? Remember, that's because H sub A was what? Less than a number. Just wax on. Anyone? Which color is two-tailed? Green. So it's this picture. Now, I made this mistake first hour, and actually I stopped the video here because I also had same internet problems. I made a mistake. Do you look up 2.14 for Z? No, as a matter of fact, 2.14 for Z should be an awfully high area, right? And look at the area that I have listed there. It's because I found this one, because the idea of 2.14, it's 2.14 to the right and 2.14 deviations to the left. Just look up this one and double it, and it's easier. So hopefully that makes sense. And it took me some stuff to figure that out, and hopefully I'm going to explain it well for you. And now what does that mean? Well, that means P is greater than or equal to alpha, which is the opposite of the last one. So that's a fail to reject the null hypothesis. I guess we really can't call it a confirmation of it. It's just okay, I guess. Yeah. Again, remember, we're giving you just a little thing here of introductory stuff. Right-tailed, of course, is the blue. So understand that when I look up Z, this is 1.95, but it's giving me this answer, all of this area. To get the blue, I have to do 1 minus that because of how the sheet is constructed. And then it's barely a rejection, but it is because it is a little bit bigger. Okay? Now I'm going to try something here, see if I can pause. That's a no. That's a yes. See how that came up in the corner? I don't want to bore anyone online, you know, with silence for too long. Is it math related? Okay. Is this going to take long? You look it up on the table, which that was the stuff you didn't do the last 3 weeks. I'm just being honest. I mean, you know what? So you got some catching up to do. This chart that I had was holding up. I have it over there. Okay, I don't because I'm not giving you that one because someone took 10 of. Are you the 10? Okay. 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 Click to resume. I hope this is okay. It always seems to it gets Okay, I hit it. All right. All right. So I think we're good. All right. Whew. Okay. We're still moving. So hopefully that pause worked, so the people online didn't have to listen to silence as we were finishing the notes. Of course, they just had to listen to all that. All right. So now, excuse me. How do you find the Z score? Now this could be a little different. I think I have to look some stuff up for you here. That's different than your Z score formula before. All right, so we need to write that down. And then I yelled at first hour and fifth hour because you got to have an ability to find numbers correctly. So, when I ask in class that kind of funny thing, all right, guys, what'd you get? And all you look at me and then, like that one student that does this to me, I ain't doing that. Forget you. All right. Well, you're actually hurting yourself. So when we actually throw numbers in this formula, just test your ability to get the number. And if you have a calculator that can do fractions, then type it in exactly as it looks, as crazy as this looks. If you don't, I don't want to get the pen out. What you'd need, though, is parentheses around the numerator divided by parentheses around the denominator. And then press enter. And then test yourself when we actually have a number. Numbers. Okay? Now, steps for doing a hypothesis test. 3 of these 5 you've already done, like I tried to get you to understand. Well, let's look at the first one. And this is your map and how this actually gets done. You did this the last 2 days. Read the question, state the null hypothesis, the alternative hypothesis, which one's the claim, the type of test, and then remember it's based off of whatever the alternative hypothesis is, less than, greater than, or not equal to. All right? Then identify, this was useless yesterday because I gave you the p-values because just like McGrath did a great job just kind of weaning you into this. Day 1, right after break, just a nice little easy worksheet. Day 2, setting up the premise. Day 3, adding, like someone said in here, math, or it was fifth hour. So now we're actually going to have to identify these numbers and then look at these numbers pertaining to this formula. That's what these numbers do in order for us to be able to find the Z-score. So this is the second new thing of the day. But of course, you got to do this first before you can do this, which we just had our last example. Now that you have the Z-score, then you could go to your sheet, find the appropriate area. Is it a left tail, right tail, two tail, like the last example, and identify the p-value. So 3 and 4 are the only new things today, because 5 is what you did yesterday as well. That last sentence that I'll be looking for on your worksheet, then make a decision. And it's based off of how I started these notes to begin with. What is P compared to alpha? And then look at these capitals. Write a conclusion. I guess we don't need to write that. It is kind of redundant. I don't care. I don't like redundancies either. So remember the writing for H, our null hypothesis and adjacent. We didn't really. Although I was kind of mad that you didn't. But all right, and then I'll try to pause it again. Yes. It's working. Okay. And someone just died outside. Is there a problem? I can't leave. I got. Eh. Now, the next question will have these steps written again. Please don't write them again, right? You're just going to go 1, 2, 3, 4, 5. But I just did that for no purposes. You don't take forever on this. I almost said the wrong thing. Okay, here we go. Again, these are going to be on this page again, so. Geez, takes so long. All right. So, like I said, these steps will be rewritten on the next page. Don't rewrite them for note purposes, but if you were behind, then go ahead. And then that little graph over there, that's just to reiterate the situation. So, just for purposes of hearing my melodious voice, plus giving the students in class time to write this, the average cost of a house in New Bern, North Carolina. I wonder if that's where she moved. She did go to North Carolina, Mrs. McGrath. That'd be interesting. Is 143,260, according to Realtor.com. This might be based on. Sorry. To test this claim, Chase Bank samples 30 houses, and the average price is 151,520. The standard deviation for all houses. Maybe I didn't make this significant enough, but I did say at the beginning. This is when the standard deviation of the population, a parameter, is known. That's what today is about. That's how the notes started. And that's what's being stated right here. This is a population parameter. Test the validity of the claim at 0.05. That means a 5% level of significance. Okay, so hopefully my reading you caught up. And like I said, do not rewrite all of that sentence. But step one is to do this. So the first thing, and you should step it out. This is like a map. Okay, this is how I structure it. That's what math teaches, structure. So follow the structure. What is given in that first sentence? Is it the null hypothesis or the alternative hypothesis? The average cost of a home in New Bern, North Carolina is $143,260. It's the null, and what's the sign? Equals. All right, and then because of that, the alternative hypothesis is not equal. What does that make it? A left-tailed, right-tailed, or two-tailed? Two-tailed. Okay, so that's what I'm going to let that be written as. So, or reveal that. And that's your job. We did that yesterday. That's not new. Second thing, and I'll pause if I need to. We did this yesterday, but we didn't need it because I gave you P. Now we need it. Remember X bar is the sample mean, and then sigma lowercase is the population standard deviation. Alpha is level of significance. What's N? Sample size, as always, which is 30. No particular order. All right, and then of course, we're going to speed this up. Remember, step 3 is to calculate that z-score then through our new formula. Now, this is the point where you should test yourself on your calculator. Can I get 1.51? Okay, so as you're writing this, I think I am going to show the next parts and yammer on and on and on. Because I think the next example, it's the same exact. I'll just go hit, and show you. And then you could just look at it and go from there. But now to calculate the area and calculate the p-value, remember this is two-tailed. So remember this is 0. I should have had that. I should have put one where it had 0, 1, 2, 3, 4, or 1, 2, 3, and then 0, 1, 2, 3. But 0, 1.51, but it's two-tailed, so we also need negative 1.51 over here. So again, it hammers down the point that I want to go to the negative 1.51 because that's how my sheet is constructed. It gives me the area left of that. And then all I have to do is double it. So then I'll get that area total. So hopefully that makes sense why that happens. And then now, if you did your homework appropriately yesterday, step 5 is what you did yesterday. So now that I have that p-value, now I can make my comparison. So P is 0.1310, which is bigger than 0.05. Is that a reject or a fail to reject? Okay, so that is a fail to reject H sub 0. or the null hypothesis. So that means we don't reject the 143,260 claim. So we could say there is sufficient evidence to indicate that the average cost of homes in New Bern is 143,260. Okay. Or you could say I fail to reject this hypothesis. One way or the other, it doesn't matter. They both say the same thing. I'll try this one more time. Kind of liking this now. Now it's kind of working better. La 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 la. I just like seeing that bar go up and down. Ah! I just want to see how high I can get it. You think I can get it all the way?
Probably.
Okay, ready? I'm going to try it. Ah! That's it didn't even go that far. Ah! Never anyone hear that Chewbacca thing? You did. Can't get it. I'm upset with my my range.
I'm upset with my
I
range.
can't get past the halfway mark. Anyone in choir or something? There should be some choirs. Do you? What's your? Aren't there like levels of voice? Like what's that called? Octaves or something?
Well, octaves is just like how high or low the sound is, but there's like different types of.
What kind of thing would make this bar go higher?
Well, that's decimal level.
Oh, what's a Do you have high decibels? Is that like someone that can break glass? Someone that can break glass when they're.
That's with frequency.
Oh, frequency. This is all different. Okay.
I did it. Got the number.
Okay.
Thank you.
Now, for purposes of the next question, I did this all day long. It's just the same thing with a different question. So I'll just read it real fast. If you don't want to listen, that's fine, but don't bother me. Pizza shop claims that the mean delivery time is less than 30 minutes. Is that a null or an alternative hypothesis? Is less than 30. It's an alternative. Okay, so we start with that, and I'm just going to read that first sentence and then just write that and then say it's a left-tailed because of what's given. And if you want to take, I'll just freeze it at when I'm done with this one if you want to take this later. Careful study has indicated that the population standard deviation for all deliveries forever is 3.5 minutes. Test validity at the claim of level of significance of 1%. Oof. Okay, these values are all given very succinctly into this. You sample 36 deliveries. The mean time of delivery is 28.5. Standard deviation to population. Level of significance. Next. Okay, you use these to calculate the z-score. Shove in the numbers. And then when I'm done with this, you can test yourself before you wreck yourself. Find the corresponding p-value. Again, this is a left-tailed test. So I just have to look up. Oh, I thought I had a drawing for this. Let's see if it comes. Yay! I thought I remembered. This is a left-tailed test. So yeah, I'm just going to look up negative 2.57. And it is that area that I have shaded there. That's how the sheet works. So that is my area that I want. So that is my probability. Then when I look at this, this is smaller than P. Now remember what that means. It's always in relation to the null hypothesis. So that means we reject the null hypothesis. We reject the idea that it is greater than or equal to 30. That means there's sufficient evidence to claim that the deliveries of all deliveries is less than 30 minutes. You could say it one way or the other, but you really want to put it in terms of the claim. So you want to put it in terms of, in this case, the alternative hypothesis, which I hope makes sense. Okay, so I will freeze the screen and allow you to take that since I went over that fast, but I don't want to bore people online. Too late.